This is part 1 of Secondary 1 Math Lesson 11-4. The warm-up, reviewing what we did last time, we're going to multiply each polynomial, write the answer in standard form. So 6y to the second times negative 4y is negative 24, y to the third power. 6y squared times 1 is 6y squared. It's in standard form because y to the third will come before y to the second. Okay, number 2. This one is where we have the binomials we're going to distribute. So negative 3m times 2m is negative 6m to the second power. Negative 3m times negative 5 is positive, because negative times negative is positive, 15m. 1 times 2m is 2m. And 1 times negative 5 is negative 5. So that's going to be negative 6m squared, and then these two terms in the middle, 15m and 2m, is 17m minus 5. So that's my product. Okay, number 3. 8x times 8x is 64x to the second. Remember, we're multiplying. 8x times 5 is 40x. Negative 5 times 8x is negative 40x. And negative 5 times 5 is negative 25. So combining my like terms, I'll have 64x to the second power. 40 minus 40 is 0, gone. And then minus 25. Okay, number 4. 6p times negative p. That means times negative 1p. So 6 times negative 1 is negative 6p to the second power. 6p times negative 2 is negative 12p. 10 times negative p is negative 10p. And 10 times negative 2 is negative 20. Okay, so when we combine our like terms, we're going to have negative 6p to the second power. Negative 12 and negative 10 is negative 22p. Don't forget that. And then minus 20. Okay, number 5. This is a quantity squared, so you have to write this out. Remember, don't take a stupid shortcut. It won't work. Okay, so we're going to do 4b times 4b. That's 16b to the second power. 4b times negative 7, watch your signs, negative 28b. Negative 7 times 4b is negative 28b. And negative 7 times negative 7 is plus 49. Combining my like terms, I'll have 16b to the second power. And then in the middle, I've got negative 28 and negative 28. That's negative 56b. Not b squared, just b. Cookie minus cookie. Okay, and then plus 49. Okay, number 6. 2v times 5v to the second. 2v, whoops, I'm a little far on that one. 2v times negative v. That's going to be negative 2v to the second. 2v times 1. So this one's a little bit different because it's a binomial times a trinomial, but it's going to work the same way. We just keep distributing until we're at the end. Okay, and then we're going to go with 8, and we're going to distribute 8. So 8 times 5v, I'm running out of room, so I'm going to write it down here. So plus 40v to the second power. Negative 8 times negative, 8 times negative v is negative 8v. And 8 times 1 is plus 8. So now I'm going to look for my like terms. I've got v squares and I've got v's. Okay, so watch your signs really carefully. What I'm going to have is I'm going to have 10v to the third. I like to cross them out as I go, make sure I don't forget anything. Negative 2v squared plus 40v squared. That's going to be 38v squared. Then I've got 2v minus 8v. That's minus 6v. And then plus 8. So when you have a binomial times a trinomial, you're going to get more terms in your final product. If you had a trinomial times a trinomial, you would get even more terms in your final product. Okay, and then the last two questions on the warm-up. Number 7, determine the degree of the polynomial. So this term has degree 4, this term has degree 2, and this term has degree 0. So the degree of the polynomial is 4. By the way, it is a trinomial. Okay, number 8, this is degree 0, and this one is degree 3. So this is degree 3, and by the way, it's a binomial. Okay, also, by the way, number 8 is not written in standard form. If I was going to write that in standard form, this is what it would be. The negative sign goes with the m to the third, so it still stays with it. Okay, so what we're going to do today is we're going to factor. And so what factoring as a verb means is it means that we're going to take apart a multiplication problem. And so if you remember, I'll just kind of cross this out. So just looking at something, if I said 12 and I said factor that, we broke it down to 2 times 2 times 3. And so that's factoring as a verb. And so what we're going to do is we're going to take a polynomial and we're going to start factoring polynomials. Now the reasons that we need to learn this are varied, but the main reason and the thing that we use this the most for is to solve equations that are not linear. And so next year you'll be using this to solve quadratic equations. So it's a really important skill that you start learning. So a couple of vocabulary words. Factor as a verb, I'm going to write that, because factor as a noun just means like 2 is a factor of 12. Factor as a verb means we're going to undo the multiplication. Okay, when we say GCF, you learned this back in elementary school the first time, but it's the greatest common factor. Okay, so think about what greatest means. Think about what common, if two people have something in common, it means they share something that is the same between them. And a factor is something like 2 is a factor of 12, or 3 is a factor of 9. So in the last lesson we learned how to multiply a monomial and a binomial, or a monomial and a trinomial. We also learned to do binomials, but we're going to just stick with the monomials and then something else today. So what we're going to do today, we're going to factor or undo our multiplication. So the first thing we have to practice doing is being able to find the greatest common factor. So let me go over how to do that. Now you did this in elementary school, or you should have done it in elementary school at some point. So if I'm looking at 12 and 18, I'm looking for the factor that they have in common that is the greatest. There's a couple of ways to do this. If you know your times tables really well, then this is a lot easier. So if you know that 12 is 2 times 6, and you know that 18 is 3 times 6, then the thing that they have in common is the 6. And so 6 would be the greatest common factor. Now let's say you don't know your times tables all that well. So what you can do then, and this works if you have really big numbers, even if you do know your times tables, this is helpful. And when we start bringing variables into the picture, this is another good way to do that. So what you can do is you can break down 12 into prime factors like we did when we did radicals. So 2 times 2 times 3. And then 18 is 2 times 9, so 2 times 3 times 3. Now go and circle everything they have in common. They have a 2 in common, and they have a 3 in common. So 2 times 3 equals 6, and that is the greatest common factor. Okay, let's try that with the next one. 8 and 20. So if you know your times tables, you might already know what the greatest common factor is, but you have to make sure it's the greatest one. You can't say 2. That's not the greatest common factor. It is a common factor, but not the greatest common factor. So 8 is 2 times 4, and 20 is 4 times 5. And so when I look for what they have in common, they have 2 times 2 in common, which is 4. So 4 is the greatest common factor. Now, if you knew your times tables really well, then you might have said, oh, well, yeah, and 8 is 2 times 4, and 20 is 5 times 4, so they have 4 in common, and that's fine, as long as you make sure it is the greatest common factor. Okay, number 3. I want you to pause the video, and I want you to try and find the greatest common factor of 3 and 4, and then we'll look at 5, where we start bringing in variables. Okay, you should have worked through 3 and 4 and found the greatest common factor. I'm going to work this out with just using the prime factors because I know a lot of you probably could do better with your times tables. So 45, if you break that down, it's 9 times 5. And 50, 10 goes in there, so it's going to be 2 times 5. So 10 times 5. So what do they have in common? They have a 5, nothing else. So 5 is the greatest common factor there. And then you guys that knew your times tables, you might have thought, well, this one is 9 times 5 and this one is 10 times 5, so they have the 5s in common. Okay, for number 4, 9 and 20. So 9 is 3 times 3 and 20 is 4 times 5. They don't have anything in common. And yeah, you can say that they have one in common, but everything has one in common, so that doesn't even count. So we would say that there is no GCF on this one. So you just would say no GCF, because not everything has a common factor. Okay, now if you can do this with integers, then we're going to bring in some variables and we're going to do the same thing. So number 5, we've got 12m to the second and 9m. So here's what I'm going to do. I'm going to do exactly the same thing. 12 is 2 times 2 times 3, so that's 4 times 3 is 12, and m to the second is m times m. 9m is 3 times m. Okay, what do they have in common? They have 3 in common, they have m in common. There's nothing else there that's in common, so 3m is my GCF. Okay, let's look at number 6. 24 x to the second y. And so 24, you can say 2 times 12, 6 times 4, 8 times 3. So I'll say 2 times 12. And then x to the second is x times x and then y. So I'm breaking everything down to the smallest possible unit. The next one is 8xy. So I'm going to say 8 is 2 times 4 times x times y. So what do they have in common? They have 2 in common, 2 in common, 2 in common, x in common, y in common. So 2 times 2 times 2 times x times y. 8xy is my GCF. So you need to be able to find the GCF of numbers like this because we're going to be using that in order to be able to factor polynomials. Okay, so let's do a couple more with variables and then we'll go to factoring. So pause the video and try and find the GCF of 7 and 8 and then turn the video back on. Okay, number 7, 36 n to the second, m to the third, which by the way that's not in standard form because it's not in alphabetical order. Okay, 36 is 6 times 6. And then n to the second, m to the third. 6 n to the third m is 6 times n to the third times m. Okay, what do they have in common? They have 2, they have 3, they have n, another n, and they have an m. So I'm going to come down here and write 2 times 3 times n times n times m. So my greatest common factor is 6. I'm going to write this in standard form. mn to the second. Okay, now as far as do you have to write it in standard form? Yes, you should be writing it in standard form. That's just a given. We shouldn't have to go through that every time. Okay, number 8. So I'm going to scoot over here. W to the fourth, x, y to the second. That's w to the fourth power, x, y to the second. Okay, 5, w to the third, y to the second is 5, w to the third, y to the second. What do they have in common? They have w, w, oh, and another w, y, and y. So they've got w, 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 y, y. So that's w to the third power, y to the second power. And that's the greatest common factor. So you're not multiplying these together, you're pulling them apart and you're finding out what they have in common. Okay, so what we're going to do is now we're going to use this to undo multiplication. So we're going to be looking at something that's already been multiplied together. So number 9, we have an expression. And so what I'm asking you is I'm saying what times what is equal to 21x minus 14. What did I have to multiply in order to get that? The number one rule when you're factoring is find the GCF. If there is a GCF and you don't find that first, you are not going to get the problem right, most likely. So the number one rule, and this will not change when we do other things and other ways to factor, this is always the number one thing you look for, is the GCF. So what I'm going to do is I'm going to take each term and I'm going to find the GCF. So 21x, that's 3 times 7 times x. And 14 is 2 times 7. Okay, what's the GCF? It's 7. So what I'm going to do is I'm going to write 7 out here. That's one of my numbers. 7 times what? So I'm going to take 7 and I'm going to multiply it by something, and I'm going to get 21x minus 14. So I think, okay, 7 times what gives me 21x? So it's kind of like a puzzle. So 7 times something is 21x. Well, 7 times 3 is 21, and then if I multiply by x, there you go. Also, you'll notice what's left when you found the GCF was 3x. Okay, the next thing is the sign. This was a minus sign in the middle, so I'm going to put a minus sign in the middle. Okay, the next question that I need to answer is 7 times what is going to be 14? So 7 times something is equal to 14. Well, here again, notice what was left when I found my greatest common factor. It's going to be 2. So my answer to the question, factor using the GCF, is this right here. This is factored. And so this will be what we're looking for. So if we're telling you to factor an expression, we're looking for you to break it down into two factors. Something times something is equal to that product. And so the GCF is what we're going to be focusing on today. So let's do number 10. Take the two terms, so 24m and 8. Let's break them down. 24m is 2 times 12 times m. 8 is 2 times 4. Okay, what do they have in common? 2 times 2 times 2. So they have 8 in common. So I'm going to write 8. 8 times something is my 24m plus 8. That's what I'm trying to get. So 8 times something is 24m. Look back at where I did my GCF. You see what's left over that wasn't in common? 3m. The sign that was in the middle is a plus, so I'm going to put a plus right there. What was left over here? There was nothing left over, so should I put a 0? No, you shouldn't, because if you put a 0 right there, 8 times 0 is 0, and that's not what we wanted. What I'm looking for is 8 times what is 8? So it's going to be a 1. And you have to have the 1 there because adding 1 is not the same as adding 0. So my answer to this question, number 10, is 8 times the quantity of 3m plus 1. Okay, let's have you guys try a couple. So try number 11 and 12, pause the video, and see what you can do to factor those out. Okay, 18x to the 4th power and 9x. Now once you guys get enough practice, and so for some of you it'll take longer than others, but when you have enough practice you won't necessarily need to write this stuff out. So like when I factor, I don't need to write any of this out for myself, but I'm writing it for you because a lot of you still need to do that. You haven't had any practice yet. So 18 is 2 times 9 times x to the 4th. And 9 is 3 times 3 times x. So what do they have in common? They have 3, 3, x. So 3 times 3 is 9 times x. Okay, so 9x times something. I'm going to be getting a binomial, so I know I have to have something, a binomial in the middle there, or in the parentheses. Since there's a plus sign there, I know I'm going to have a plus sign right there. So I just need to figure out what the two pieces are. And so I can look at what I have left over. I had a 2, and I had x to the 3rd power. Okay, check it. 9 times 2 is 18, and x times x to the 3rd is x to the 4th. And that's what I had to begin with. So you see, I'm just undoing, I'm picking apart the multiplication problem to find out what I multiplied. It's kind of like a little mystery, find out what happened. Okay, the 9x, I don't have anything left over, so that means I've got a 1. And that's your answer. So your answer will look like a multiplication problem. Okay, so the next one, I've got 3 terms. So don't let that freak you out. 5 times k times k times k. 8 k to the second, that's 2 times 2 times 2 times k times k. And then the last thing I've got is just k, so it's just k. What do they have in common? The only thing that they all 3 have in common, it has to be all 3. It can't just be 2 of them. It has to be all 3 of them. The only thing they all have in common is k. So that will be my GCF. So I'm going to multiply by something and get a trinomial. So I'm going to have 3 things in there because that's how I'm going to get a trinomial. Now look at your signs. Since this first one's a negative, I'm going to need a negative, and this one's a positive, I'll need a positive. Okay, so it's kind of like just a little puzzle. You get all the little pieces. Okay, so k times what gives me the 5k to the third? So you can look back at your GCF work and you can say, well, I had 5k to the second power, so that's what's going to go right there. Actually, I probably better write that a little bit better. 5k to the second power, and then I've got a minus sign. Okay, and then what do I have next? I had 2 times 2 times 2 times k, 8k. And then what did I have down here? I didn't have anything there, so I'm going to write 1. Now, the thing to remember about factoring, and this is a really important thing to know, is that you can always check your work. So when you multiply it back through, you should get what you started with. Okay, I'm going to end this video, and we're going to finish up with another short one to do the last few questions.